Welcome, everyone. I'm excited to kick off today's presentation on estimation. This is our first slide, and I want to warmly welcome you all. We'll be exploring key concepts around estimation, and I'll give you a quick overview of what's to come. We'll cover methods, best practices, and some practical insights. But for now, let's keep it brief and get started. Let's talk about the concept of an estimate. An estimate is essentially a probable cost of a work. It's usually prepared before starting the actual construction, so we have an idea of what the project will likely cost. The main purpose of an estimate is to know the cost beforehand, which helps in planning and budgeting. Now, keep in mind that the actual cost is only known after the work is completed. If we prepare our estimate carefully and accurately, there shouldn't be much difference between what we estimated and what the actual cost turns out to be. That's why precision in estimating is so important. The estimator needs to be well-versed in construction methods, and they should be skilled and experienced to ensure the estimate is as accurate as possible. In the end, a good estimate helps us manage costs effectively and set realistic expectations for everyone involved in the project. When preparing an estimate, there are several key pieces of data that we need to gather. First, drawings are absolutely essential. These include detailed plans, elevations, and sections, all drawn to a specific scale. They help us accurately measure and understand the various items of work involved. Next, we look at the specifications. These documents tell us about the nature, quality, and class of the materials we'll use. They also specify how the work should be executed, including workmanship and labor requirements. An important point here is that the cost of the work can vary significantly depending on these specifications. For example, using cement mortar with a 1:3 ratio is more expensive than a 1:6 mix because of the material proportions and quality involved. Finally, rates are crucial. We need up-to-date rates for different work items, material costs, and wages for various categories of labor. It's also important to consider the location of the project, the distance from sources of materials, and transportation costs, as these all influence the overall estimate. Typically, we obtain these rates from standard schedules of rates prepared by engineering departments, which serve as reliable benchmarks. All of these components, drawings, specifications, and rates, are interconnected and form the foundation for accurate and realistic project estimates. Let's take a closer look at the different types of estimates. First, we have the plinth area estimate. This method involves calculating the plinth area of the building, which is essentially the measured footprint at ground level. To get the cost estimate, we multiply this area by the plinth area rate. Now, this rate isn't arbitrary. It's derived by comparing the costs of similar buildings with similar specifications in the same locality. This helps ensure the estimate reflects local market conditions. Next, we have the cubic area estimate. Instead of just looking at the footprint, this method considers the entire volume of the building. The cubic rate is determined based on the cost of similar buildings in the area that have comparable specifications. To find the total cost, we multiply the building's volume by this cubic rate. One key advantage of this method is its accuracy. It tends to be more precise than the plinth area estimate because it accounts for height and volume. Finally, there's the estimate per unit base. This approach is very flexible and is often used for preliminary planning across different types of projects. For example, for schools and hostels, we might estimate costs per classroom or per bed. For theaters, it could be per seat, and for roads or irrigation projects, per kilometer. Bridges and culverts are often estimated per running meter, and sewerage or water supply schemes are estimated per person served. This method helps provide a quick, yet reasonably accurate, estimate tailored to the specific nature of the project. Connecting these points to our overall theme, understanding these different estimation methods allows us to choose the most suitable approach based on the project's specifics and the accuracy needed. Let's look at some practical examples to understand how we can calculate costs using simple multiplication. First, consider the scenario where the cost of constructing a school building is Rs. $25,000 per student. If we want to find out the total cost for 100 students, what do? We multiply Rs. 25,000 by 100, which gives us Rs. 2,500,000. This shows how per-unit costs can be scaled up to larger numbers. Next, think about building a highway. If constructing 1 kilometer costs Rs. 10 million, then what would be the cost for 20 kilometers? Again, we multiply Rs. 10 million by 20, resulting in Rs. 200 million. This example reinforces how multiplication helps us easily extend costs over longer distances. Finally, let's consider a residential building. If the plinth area rate is Rs. 10,000 per square meter and the total area is 100 square meters, how do we find the total construction cost? We multiply Rs. 10,000 by 100, which equals Rs. 1 million. The key takeaway here is that understanding these basic calculations allows us to estimate costs efficiently across different projects, connecting the concept of unit rates to real-world applications. This is fundamental to budgeting and planning in construction projects, which ties back to our overall theme of cost estimation. Let's take a closer look at what goes into a detailed estimation. When we're estimating the cost of any building or structure, there are a few essential elements we need to have in place. First, we need accurate drawings, which give us a clear visual of the project. These drawings help us understand the scope and design details. Next, detailed specifications are crucial. They outline the materials, standards, and workmanship required for the project. Finally, we need rates. These are the unit costs for materials, labor, and equipment. Combining all these components allows us to develop a comprehensive and precise cost estimate. This process is fundamental because it ensures that all aspects of the project are accounted for, helping us stay on budget and plan effectively. Throughout this presentation, we've emphasized the importance of thorough planning, and detailed estimation is a key part of that. It connects the design phase with the actual construction, making sure everything aligns financially. Let's take a closer look at the key steps involved in construction. First, we have the planning phase. This involves preparing detailed drawings, including plans, sections, and elevations. These drawings need to include full dimensions and specifications that meet the requirements of the proposed structure. Think of this as creating a clear blueprint that guides the entire project. Next comes estimation. This step is about calculating the overall cost of the structure. It's crucial because it helps us verify if the available funds are sufficient or if we need to secure additional financing before moving forward. Accurate estimation ensures the project stays within budget and helps avoid surprises down the line. Finally, we reach the execution or construction phase. This is where all the planning and estimating come together. It's about groundbreaking the proposed structure and building it according to the drawings and estimates. Essentially, it's translating the plans into reality, making sure everything is built as designed and on schedule. Connecting these points, each step builds on the previous one and is vital to the successful completion of any construction project. Proper planning, accurate estimation, and careful execution are the backbone of a well-managed construction process. Let's talk about the fundamental aspects involved in estimation and costing for construction. First, we have the concept of quantity. This refers to the measurement of materials or work needed, which is based on the drawings, like the plan, elevation, and section views. It's about accurately quantifying what's required for the project. Then we have quality, which deals with the specifications. This includes the properties of the materials used, as well as the workmanship involved. Essentially, while quantity tells us how much asterisk, quality tells us what kind asterisk of materials and work standards we need to meet. Both of these points are crucial because they directly influence the overall cost and success of the construction project. Precise measurement ensures we don't underestimate or overestimate, and adhering to quality standards ensures durability and compliance. Connecting this back to our overall theme, understanding these two aspects helps us achieve efficient and cost-effective construction planning. It's the foundation for accurate estimation, budgeting, and ultimately delivering a successful project. Let's take a closer look at the objectives outlined on this slide. First, it's essential to know the quantities of various items of work, including materials and labor. This means accurately estimating what's needed and understanding where to find the information about these quantities. Having a clear grasp of this helps us plan effectively and avoid surprises down the line. Next, we need to decide whether the proposal can match the available funds to complete the structure. This is a crucial step because it ensures our project is financially feasible. If the costs exceed the budget, we might need to revise our plans or seek additional funding. Third, obtaining the administrative and technical sanction of the estimate from the relevant authorities is vital. This step is what officially approves our costs and estimates, allowing us to release the necessary funds for construction to move forward smoothly. Finally, once we have the approved estimate, we invite tenders or quotations. This means requesting bids from contractors or suppliers based on the estimated quantities. It's the process that enables us to select the best value for the work and ensures transparency and competitiveness in awarding the contracts. All these objectives are interconnected and serve the overall goal of managing the project efficiently, from planning through to execution. They help us stay on track financially, technically, and administratively, ensuring the success of the construction process. Now, let's move on to the methods of taking out quantities for various items of work. As you know, in construction, we often need to estimate quantities for earthwork in excavation, foundation concrete, stone masonry in the foundation and basement, as well as stone or brick masonry in the superstructure. To do this effectively, we primarily use two methods. The first is the long wall and short wall method, also known as the general method. This approach involves calculating quantities based on the dimensions of long and short walls, which simplifies the process when dealing with rectangular or regular-shaped structures. It's quite straightforward and widely used for its simplicity. The second method is the center line method. This technique is particularly useful when dealing with irregular shapes or structures with complex layouts. Instead of measuring the actual wall dimensions, we work based on the center lines of walls, which helps in accurately estimating quantities for more intricate designs. Both these methods are essential tools in our estimation toolkit, and choosing between them depends on the specific project details and the shape of the structure. By understanding these methods, we ensure our estimates are accurate and reliable, ultimately leading to better project planning and cost management. Let's talk about the long wall, short wall method. When we're measuring the length of a long wall from out to out, we start with the center to center length. Then, we add half the breadth on one side and half on the other side. This simplifies to the center to center length plus one full breadth. Now, for short or cross walls, the approach is a bit different. Instead of adding, we subtract one breadth from the center length. This gives us the in-twin length of the short wall. Then, just like with the long walls, we adjust by subtracting one breadth to get the in-twin measurement, which helps us accurately determine the internal dimensions. The key thing to remember is that for long walls, we're adding half breadths to reach out to out, and for short walls, we subtract a breadth to get the in-twin length. This method is crucial because it helps us quickly and accurately calculate wall lengths based on their orientation and position relative to the centerline. By understanding this approach, we ensure our measurements are precise, which is fundamental for reliable planning and construction. Let's now discuss the center line method. This approach is known for being both easy and quick when it comes to calculations. Essentially, what you do is find the total length of the center lines of all the walls, whether they are long or short. This simplifies the process because instead of measuring every detail, you focus on these center lines. This method works particularly well when dealing with walls of similar cross-sections, because the calculations become more straightforward and consistent. The key idea here is that once you have the total length of the center lines, you multiply that by the breadth and depth of the items involved. This gives you the total quantity needed for each item, which is quite efficient. Another important point is that the length remains the same across various stages like excavation in the foundation, pouring concrete, and for all footings and the superstructure. This uniformity makes the center line method a practical choice for estimating quantities in many construction projects. Overall, it streamlines calculations and helps ensure accuracy across different phases of construction.